Okay, so I can spell it out in the form of a kind of recipe. So there's a two-step recipe. Now, all this takes place in the context that your f here is homomorphic. Okay? If it's not homomorphic, then all this theory does not follow. So in both these two examples that I have enough whiteboard for, I proved, from Barnard, proved that the function, your mapping, your f here, is homomorphic. All right. Well, let's do two. I'll do the third one on the next board, the next session. Let's find solutions to z. You know, what are the values of z? Z is just a complex number, okay, such that z cubed is equal to 8i. Square root of -1. All right. So I guess perhaps I should have. Well, let's first prove that this function here is homomorphic. Right. Remember how to do that from the previous lecture? F of mn equals fm times fn. Right. So let's just prove that in a line or so. So f of z is homomorphic, and the proof of that. So here's your fm, fn, and we'll prove that it's equal to f of mn. Okay. So what is f of z1? Well, it's just z1 cubed, and f of z2. Well, what's that? Given this definition. Well, that's just z2 cubed, right? But you can rewrite that as z1, z2 all cubed. Okay. But what's that? Well, it's f of z1, z2, right? From this definition. Hold on. Just a minute. Here. Yeah. Okay. So this f is homomorphic. All right. Now, let me talk about the recipe, and then we'll apply it to here. This being the first particular case, and this being the second. All right. Now, to find a solution, find solutions. Little g or x, same thing, effectively. You need to know what your kernel is, right? So find what your kernel is. So find the members of your kernel. They're all elements in your G that map to H, the unit of H. Right? So that's your first step. So in other words, find the set of x, little x that belong to G, so that they map to the unit of your H here. Right? So in this case, the kernel would be all those elements Z, complex numbers, that map to 1. Right? Why 1? Well, that's the unit. That's your unit element here. Right? Because the binary operation here is not plus, it's multiply. Okay? So your unit will be 1. Right? So just find a solution to that, and let this be my little a, in a sense. F of something maps to a, little a, and all right. So what? So let a little a be 8i. So we're trying to find a solution to this, because f of z, or z, is z cubed. Z cubed is 8i. So we're trying to find a solution to this problem. F of z equals 8i, right? Well, here it is rewritten. F of a equals. Hold on. Have I got that correct? If it's z equals 8i, that's your little a, right? And then so you found a solution, little a here, which belongs to the coset A kernel. That's the kernel's the set of all elements mapping to the unit of this, right? And that'll be a set of solutions, because every element, like all your f of somethings, if they all equal a, then one of the theorems we just did, where was it? Yeah, so if you have two elements that they map to the same thing, then they belong to the same coset of the kernel. Okay? So all those elements that map to, say, little a, they will belong to the coset a bar, or ak. So if we can find a solution a, then we just multiply it by the kernel. Right? So, or if you like, all the elements in the kernel get multiplied by this solution, little a. Now what I've just said is important, right? That's the essence, that's the heart of these two techniques, right? So in a two-step process, take your problem, show that the mapping F is homomorphic, then find the kernel, your K, for that mapping, for your F. Find one solution, like little a, and then to find all the solutions, multiply your solution, little a, by all the elements in your kernel. So AK, to give you a bar. And that'll be all the solutions to your problem. Now, in this case, the problem is z cubed is 8i. All right? Okay, so we've proved, so let's assume that the function is this. This is what the mapping is, f. We just showed that it's homomorphic, right? So therefore all this theory applies, theorem 62, 63, etc. Okay, so all those theorems apply. Now let's find a solution little a to this problem. And the problem is, z cubed is 8i. Now z cube's f of z, we're assuming. Okay, so f of z is 8i. So that's our little a, right? That would be like here. F of g is little a. And here we've got f of z is 8i. Now what's the solution to that? So z cubed equals 8i. Well, one solution is just 2, if you cube that you get 8, and e exponential to the power pi I over 6. Where'd that come from? Well, you know what, I is what? The famous Euler formula, e to the pi I equals -1, right? So square root both sides, so you'll get e to the pi I divided by 2 equals square root of -1, which is I. So e to the pi I over 2, e to the pi I over 2, and then divide by 3 because we're taking the cube root, so you'll get e to the pi I divided by 6. Okay, that's where that comes from. So there's one solution. That's your little a. Okay. Now, how to find the kernel? So this step here. How to find the kernel. So there are all the solutions of this that map to the unit of your h. In this case, it would be where? Right. Well, the unit is just 1, right? Because the binary operation here is multiply. So the unit in h here will just be 1. So we need to find the the kernel, you know, the set of elements that map to 1. Not 8i, just 1, right? Well, here's your kernel. Here are the solution, 3 of them, that map to 1. Now, so the answers are 1, e to the 2 pi I divided by 3, and e to the 4 pi I divided by 3. Where did these come from? Well, I'm assuming you know enough complex number theory. I will be giving a course at senior and first year master's level, probably sometime this year, 2012, on complex analysis. So effectively the calculus of complex numbers, so differentiating and integrating complex numbers. But I need you need to know enough already to be able to figure out where these values came from. I mean, just quickly, e to the pi I is -1, Euler's famous formula. So if you square that, so it'd be e to the 2 pi I is +1. Right? You're squaring both sides, so you get +1. So e to the 2 pi I. And then you're taking the cube root of this, so it'd be e to the 2 pi I divided by 3. E to the 2 pi I divided by 3. So that's where that one comes from. But e to the 4 pi I is also +1. And e to the 6 pi I is also +1, and so on. So that's where these other two come from. Just divide by 3. Anyway, so there's your kernel. Okay, there are your solutions to this problem. Right? Okay, so we've got the kernel. We've got a solution, like the little a. That's this, right? And then we just multiply it. We just find a, little a, big K, or a bar, right? So we're now doing something concrete using this more abstract theory, right? So we're now finding a bar. All right. So the full solutions are so that's like your little a here, and K for your kernel. So we just multiply this into all 3 values of K, your kernel. So we multiply 2e to the I pi over 6